Welcome to today's lecture. So, I will start with a brief recap of what we had discussed in last lecture. So, in last lecture we began with standard deviation, we had a recap about z-score and plotting box plots. Now, and towards the end of last lecture we had discussed about moments as a way of characterizing data. Okay. So, the definition of moment, as you would recall, is in general. So, given a set of observations yi of a variable y, the rth sample moment about 0 is defined as mr star is equal to summation y to the power r by n for r is 1 2 3 dot dot dot. Okay. So, clearly if we set the value of r equal to 1, so m1 star is summation y by n, which is nothing but the mean. So, in other words, the first moment about 0 of a set of observations is the mean of the distribution. Okay. So, we can next go define in a more general sense the rth sample moment about any particular value, and in particular we want to know the rth sample moment about the mean. So, the rth sample moment about the mean is defined by summation y minus y bar to the power r by n for r equal to 1 to 3 dot dot dot. So, clearly, so when you say about the mean, if we are to generalize it about a value a, instead of y bar we will put a value of a. Okay. So, again as before we did, if we put the r equal to 1, so first moment about the mean is summation of y minus y bar whole to the power 1 by n, and summation y minus y bar is going to give you a value of 0 as we had determined in last lecture. So, first moment about the mean is 0. What about the second moment about the mean? If let us say, so n is reasonably large, so your m2 is nothing but summation y minus y bar whole square by n, and you can clearly see that this is nothing but very close to what is our definition of the variance. Okay. As opposed to dividing by n minus 1, we have divided by n, but for n large your m2 is nothing but the sample variance. Okay. Again we can use it for calculating higher moments like third moment about the mean, y minus y bar whole to the power 3 by n. So, one aspect that we discussed in last class was depending on the nature of the distribution, all odd moments about the mean. So, which means that m1, m3, m5, m7, so on and so forth will return you a value of 0. This is because for every value of y which is situated to the left of y bar, so there is another value of y which is situated to the right of y bar, and their frequencies of these two values are equal, which means that for every negative value that you accumulate for let us say y1 minus y bar, there is a corresponding y2 minus y bar which is positive and equal value. So, these will cancel each other out, eventually giving you a value of m3 or m5 which will be equal to 0. But of course, for a non-zero, for a asymmetric distribution, this value is not going to be 0, it will have some value. Now, depend the way these moments are defined, if you have a value of y which has a given unit, then this mr will not return you a value which is unitless, but rather it is unit, it has some units. So, you of course want to eliminate that that aspect of dimensionality in your measurements, and for that purpose what you typically do is you divide by another moment which is raised to some other power, so that the units are the same. So, a3 is one such measure. It is defined as summation of y minus y bar whole cubed by summation of y minus y bar whole square whole to the power 3 by 2. So, this is nothing but m3 by m2 whole to the power 3 by 2. So, this is of course unitless, as you can see from the definition. This is called skewness. So, we had worked out, so logic we had reasoned that if you have a distribution which was like this, so this is y, this is frequency, so your mean is somewhere here. And so, all these values, so because there is a precedence of values which are to the left, so all these y minus y bar values in this domain will give you negative, and in y minus y bar in this domain will be positive, as a consequence of which there is a possibility that when you compute y minus y bar whole cubed summation, this might turn out to be negative. So, there is a greater chance that in this case that when you calculate m3 or a3, you get a value which is negative, because m2, m4, m6 are always positive, because they have y minus y bar whole square, whole fourth, whole sixth, those are always positive. So, all odd moments for asymmetric distributions may be either negative or positive depending on how the data is biased. Okay. So, another measure, so skewness of a data is basically to see differentiate between a symmetric distribution with a non symmetric distribution, either which is biased to the left or biased to the right. Okay. So, these two are asymmetric and these will give me different values. So, we had worked out an example in last class where we tried to find out what is the skewness measure for this particular population. We anticipated it would be negative, we turned out with a value which was slightly positive. But let us work out another example where let us say where we take a data which is biased to the right. Okay. So, in that case let me have these values. So, let us say our mode is 3. So, and this is 1, this is 5, I have 2 and some intermediate value 4. Okay. So, let us say I have 1 1s, 2 2s, 3 3s, 2 4s and 1 5. Okay. So, I have 1 2 3 4 5 6 7 8 9 values. Okay. So, let us calculate the mean. So, y bar is going to be 1 plus 4 plus 9 plus 8 plus 5. So, 9 numbers, which is 5 plus 5 10, 9 10 and 17 27. So, y bar is nothing but 3. Okay. So, y minus y bar whole cubed is going to be give me a value of minus 2 whole cubed plus minus 1 whole cubed into 2 plus 1 whole cubed into 2 plus 2 cubed. Okay. So, I have minus 8 here, I have minus 1 minus 2 here, okay, plus 2 here plus 8 here. Okay. So, 2 cubed is 8, 8 8. So, these exactly balance each other out, and then for this particular distribution I get y minus y bar whole cube to be 0, summation of y minus y bar whole cube to be 0. Okay. So, clearly what you see is your data is slowly shifting to the right, okay, from a value. So, but if we bias the data even to the right side even more, then we will slowly get a value which is much positive and than otherwise. Okay. There is another metric of of characterizing a distribution which we call as kurtosis. So, the kurtosis is a way of measuring the pickedness of a curve, or how flat or how sharp is the curve. Okay. So, I can have two curves, let us say this is one situation, this is another situation, this is another situation. Okay. So, what I see is the pickedness of the curves, this is increasing, right. This is called, it measures the pickedness or flatness of a curve. Okay. And it is given by this metric of A4, which is defined by summation y minus y bar whole to the power 4th by summation y minus y bar whole square. Okay. So, this is nothing but M4 by M2 square. So, if we compare our definition of A3 and A4, so A3 I write A3 was defined as M3 by M2 whole to the power 3 by 2, A4 is defined by M4 by M2 whole square. And as I said, so the aim here is to define these metrics in such a way that you come up with a non-dimensional term, and that is exactly how you have defined A4, because M4 has powers of y minus y bar whole to the power 4th. So, the definition of M4 has whole power 4, this has whole power 2. So, you have to square it to generate something which has the same units of M4, and that is why your A4 is defined by M4 by M2 square. Okay. So, let us calculate a simple example where we calculate A4. Okay. So, we want to calculate A4, let us say our data is, so let us take a very flat distribution. Okay. So, let us say our data is 1 2 3 4. So, each of these values only appear once in this case. Okay. So, your y bar is equal to 2.5. Okay. So, I can have y minus y bar 1, 2, 3, 4, y minus y bar whole square whole to the power 4th. So, this is 2.5. So, 1.5 whole to the power 4, this is 0.5 whole to the power 4, 0.5 whole to the power 4, 1.5 whole to the power 4. Okay. So, you can go through the calculation and see what value of A4 you get for this distribution versus for another distribution where let us say 1, 2, 2, 3, 4, 3, 3, 4, right. So, we have made the distribution. So, the other point let us say is slightly higher. So, we have generated another distribution. So, let us say this is distribution 1 which is completely flat, and this is distribution 2 which is slightly more piqued, because you have these 2 points which are occurring at a slightly higher frequency. Okay. Please go through this calculation and see what value of A4 you get. You can generate one more distribution where you arbitrarily let us say you make it 1, 2, 2, 2, 3, 3, 4. So, it is asymmetric. So, let us say the next distribution is asymmetric, okay, but 2 has a higher value. Okay. You can make it keep on making it more and more piqued and see what kind of value you get. Okay. So, these exercises will help you get an idea of how to go about generating or coming up with important metrics of quantifying the statistics of the data. So, in the later part of this class today, I wanted to discuss about an analytical tool or statistical, how can you use a software to do these statistical analysis. Of course, we very well saw that even for these 4 points, if you are to start to do the calculation by hand, beyond the point we are not able to do. So, we need a tool which would enable us to do these calculations if we have bigger data sets, or where the data is to be actually read from a file where you have let us say observations from 10 different experiments, so on and so forth. In that case, I wanted to introduce you to this language called R. So, what exactly is R? R is a software environment which is used for data analysis specifically. It is a GNU package, and the source code of R is freely available. So, that is the best part of it. You can, and it has a command line interface, and it has other interfaces also. So, and more importantly, it can produce publication quality graphs with mathematical symbols. Okay. So, R is essentially an interpreted language. This is a sample example of a console of R. Okay. So, you have this is, so as it is written clearly here, R is free software and comes with absolutely no warranty. Okay. So, you can download it from the net, and I will come to the details of how you can download it and how you can use it. So, what are the applications of this R language? It is used by statisticians. It was established in the University of Auckland, and it is now widely used to the extent that there are group of researchers who contribute to the further development of this language. Okay. So, it is it is used by statisticians for statistical computation and software development. R supports matrix arithmetic, and its performance is comparable to that of expensive softwares, or widely used expensive softwares like MATLAB, for which you need to purchase a license. And R can be used to perform high performance statistical computation, and to the extent that it is also used by the business fraternity. So, it brings us to the first question: how do you get R? So, R is an open source programming language. So, you can download it from this. So, there is a website called rproject.org, and the best part about it is available in all the different formats, all the different operating systems. So, you can download it for Windows, you can download it for Linux, or you can download it for Mac. Okay. So, now R itself is a command line interface. So, sometimes people want graphical user interfaces for easy use of the facility and even to understand how it is used. So, there are various GUI based softwares which run R code. So, R Studio is one such then. So, let me give you an example of how these R and R Studio work. So, this is a console of R. Okay. This is an R console, okay, and this is an R Studio console. Okay. So, when we say console, so you can download R and you can write down. So, in the console, of course, you saw the difference between R Studio and R. Here everything you have to write down and then get to your point. Here you have a way of browsing through different aspects, seeing what are the tools, viewing, and also the help file is much more easy accessible. Okay. So, you can download any of these two softwares. I recommend that you download R Studio for your use. Okay. So, that brings us to R Studio. Okay. So, we can clearly see, so this is for example the console of R Studio. So, you have three, if you look at the R Studio command, there are three different windows. This is called the workspace. So, let us say if you have generated some variables, you will see them being recorded here with the full information, and this is the main command window where you will actually enter various things to do. Okay. So, let us just do some simple computation in R Studio. So, I can open R Studio. So, I can, let us say if I want to do simple arithmetic, I can define AA as a variable and I can assign it the value of 1. Okay. I can write AA equal to 1. Now, the value of AA is not displaced, but what you see is in this section you can see the value of AA being generated and its value is obviously written here. So, in order to know exactly what is the value of AA, if you write AA and press enter, then you get a value of 1. Okay. So, similarly I can do BB is equal to 2. So, note that in statistical language, if you, irrespective of whether you give a space or not, it will still work, it will not crib, it will still work. So, in both these cases BB is also stored at 2 and BC is also stored at 2, even though you gave spaces before the equal to. But for your own clarity, it is better that when you write there is a space in between an equal to or any other symbol. Okay. So, in the R Studio console itself we can do basic calculations. So, for example, I can write AA plus BB, enter. So, I get the value of 3. I can do simple arithmetic. So, I can write AA power BB. So, that is x to the power y, right, and I can enter, I can get the value of 1. So, AA is 1, 1 to the power 2 is 1. I can write BB to the power BB. So, I can do, so 2 square is 4. I can do simple calculus. So, if I do sine of 30 degrees, so remember that for it is calculated in radians. So, sine of 30 degrees we always think it is half, but this guy is giving a value of minus 0.98. This is because it is calculating in radians. Okay. So, in order to calculate the value of sine of 30 in radians, you have to write 30 slash pi by 180. Okay. If you write, and the good part is it gives you what is the way in which you write. So, sine of x is how you have to enter this value, and within this you can do anything. If I put enter here, now I get a value of 0.5 which was not negative. So, when you are doing trigonometric calculations, you have to enter these values in terms of radians. Okay. Similarly, I can do the same thing, cos of pi by 2 will return me a value of this c. So, one thing is these things, these values are calculated numerically. So, this is the reason why you see that when its value of cos pi by 2, it is not 0, but it is coming up 6.12 whatever into 10 to the e minus 17 means 6.12 10 to the power minus 17, which is as good as 0, but it is not exactly 0, and this is because these values are internally computed by a code. So, it is an approximate. So, I can do the same thing, I can do, let us say, log of 10. So, if you see the syntax, it is log x comma base. Okay. So, I can write, so this is another way of writing is, so let us say if I do log of 10, I get value 2.3. That means that it is actually calculating the natural logarithm and not the log base 10. Okay. So, let us say if I do log 10 comma 10, so now it is giving a value of 1. So, if I enter the base and this is my number, this is the base with which I am calculating my logarithm, it is giving me the value of 1, versus if you just write log, it will give you a value with respect to the natural log. Okay. So, I can also do log 10 of 10, then also you get a value of 1. Okay. So, you can easily go through the list of these kind of inbuilt functions which do the basic calculations. Okay. Now, let us say I have 10 values, right. I have 10 values and I want to calculate the let us say standard deviation, mean or median of a distribution. How do I do it? Okay. So, what you do here is you enter, let us say data is, so because I did this, I generated this data before, it is already showing up as there, but I can rewrite data. I would use this expression C of 1, 2, 3, okay. So, let us say I enter as a vector. So, the syntax is C, and within that you put numbers, okay. By default you want to put numbers. So, when I do enter and then I write data, so what you see here, data got initialized to a row vector which has 5 entries 1, 2, 3, 4, 5. Okay. In order to type data, I should just write data and then I get back what it is, and because it is a row vector, it is showing as 1 of 1, 2, 3, 4, 5. Okay. So, now I can change, let us say I have 5 new entries, I can write data is equal to, so I can write data is equal to C of, so I had my original data and I am overwriting, adding 3 more numbers, let us say 6, 7, 9. Okay. So, I write data is equal to C of data comma 6, 7, 9. Now, if I type data, so what you see here, data has now become a 8 column entry, where in additional to 1, 2, 3, 4, 5, you have 3 more numbers which have been added. Okay. So, I can just get the value of data here by writing data and enter, and then I get this value. Now, calculating these basic metrics in R is super simple. So, in order to calculate the mean of data, I will just write mean of data and I will enter and I get the exact value, which is 4.625. Okay. I can calculate a median of data, median is 4.5. So, I have 1, 2, 3, 4, 5, 6, 7, 8. So, my median is at position between 4 and 5, and which is nothing but 4.5 by 2, which is what it is giving 4.5. Now, what is the mode of this distribution? We can clearly see that these are different values which do not have any. So, there is no particular value which has which is maximal in frequency. So, if I write mode of data, let us see what it gives. So, it says numeric, which means so this is, it is not giving an exact value, because it does, I do not have any particular value which is repeating. So, let us again change the expression for data by writing data is equal to C of data comma 3, 3, 3, 4, 4, 4, 4. Okay. This is how I modified data. I can type it here, but I can clearly see here now data is showing up as a 14 column vector. Okay. Now, once it is bigger than a certain size, of course, it is difficult to see here, but what you can do is you can write data and inquire its value. So, you have this entire distribution, okay, of data. So, I can just write now, if I do mode of data, it is giving me numeric value. So, we have to see, because now, so let us see median data, okay, it is giving me the value 4. So, now I guess if we arrange them in terms of ascending order, then 4 will be in the center, and that is why this median is giving me a value of 4. Okay. So, if I go back to the presentation, so let me just briefly say what we have done. So, you can create a custom vector. So, using this C open bracket, and then you have various entries 1, 2, 3, 4, 5, 6. In that way, you will get these values. You can enter them. You can introduce this vector as a sequence. So, I can write from 1 to 7 by 1, which means I want a sequence which is increasing in units of 1. I can generate this vector. You can repeat it. So, you have 1 which you want to repeat 10 times. You can generate this vector. You can do this repeating sequence, repeating of a range. You can generate this vector. Similarly, for a sequence you can do. So, of course, you need to remember that these are case specific. So, in one line you write B, in the next line you write capital B, you will be shown an error. Okay. So, and we briefly discussed about all these basic manipulations like addition, subtraction, multiplication, division. So, please note that if you have a vector, then when you do these sum, so let us say A is this particular vector, when I write B is A plus 1, 1 is getting added element wise. So, that is why you are adding 2, 3, 4, 5, 6, 7 from 1, 2, 3, 4, 5, 6. Okay. So, these operations operate on an element wise basis. So, which is why if you do write C is equal to A by 5, you will get this particular values, okay, or A star B. Now, if you do A star B, again it is an element wise operation. First one will be 1 into 2. Okay, so, we had modified B somewhere else. Okay, B is A plus 1, C is A minus 1, D is okay. So, A star B, you can see that this will accordingly change. Okay. So, this is A plus B, this is A star B. See, 1 into 2 is 2. In the last case, 6 into 7 is 42. So, you have these particular elements, or you can also do A power 2 exponential whatever. Okay. So, this gives you an idea of the usability of this particular language R, which is very easy to learn. You can download it, you can use it for analyzing your data. With that, I stop here. In the next class, we will do one more session with the language R to see how we can import data from, so of course, it is good enough to write 6 values, 7 values, but you have a trench of data, then you need a way to import this data into this R software and operate on them. And we will also briefly discuss how to do plotting. With that, I thank you for your attention today, and I look forward to having our next lecture. Thank you.